An updated toggle or duplex switch or outlet can be grounded to the electrical box by itself. You will need an updated toggle or duplex switch or outlet with a ground screw and a ground wire, which is usually green or bare copper. The steps are as follows. Firstly, turn off the power. Turn off the circuit breaker or remove the fuse that supplies power to the box. Secondly, remove the old device. Unscrew the screws holding the old toggle or duplex and pull it out of the box. Thirdly, identify the ground wire. Look for a green or bare copper wire in the box. If there is none, you will need to run a ground wire from the ground screw on the box to the ground screw on the new device. Fourthly, connect the ground wire. Wrap the ground wire clockwise around the ground screw on the new device. Tighten the screw securely. Fifthly, insert the new device. Push the new device into the box, making sure the ground screw is in contact with the metal box. Sixthly, screw in the device. Tighten the screws on the side of the new device to hold it securely in the box. Seventhly, turn on the power. Restore power to the circuit. If the electrical box is metal and grounded, it can serve as the ground for the device. However, if the box is non-metallic, a separate ground wire must be installed. To elaborate further, let's delve into the importance of grounding in electrical systems. Grounding provides a safe path for electrical current to flow in the event of a fault, such as a short circuit. This path helps to trip the circuit breaker or blow a fuse, cutting off the power and preventing electrical shock or fire. The ground wire is typically connected to a grounding electrode, such as a metal rod driven into the earth, which provides a direct connection to the earth's potential. This connection helps to stabilize the voltage in the electrical system and prevent voltage fluctuations that can damage equipment or cause electrical hazards. When installing an updated toggle or duplex switch or outlet, it's crucial to ensure that the grounding system is properly connected and functioning. This means verifying that the ground wire is securely connected to the ground screw on the device and that the ground screw is in contact with the metal box, if applicable. It also means testing the grounding system to ensure that it is providing a low impedance path for fault current to flow. There are several methods for testing grounding systems, including using a ground resistance meter or a multimeter. A ground resistance meter measures the resistance between the grounding electrode and the earth, while a multimeter can be used to measure the voltage between the ground wire and a known ground point. A low resistance or voltage reading indicates a good ground connection, while a high reading indicates a problem with the grounding system. If you encounter any problems with the grounding system, such as a loose connection or a high resistance reading, it's important to address the issue immediately. This may involve tightening the ground connections, replacing corroded or damaged wires, or installing a new grounding electrode. It's also important to consult with a qualified electrician if you're unsure about any aspect of the grounding system or if you encounter any difficulties troubleshooting the problem. In addition to ensuring proper grounding, it's also important to follow all other safety precautions when working with electricity. This includes turning off the power to the circuit before working on any electrical components, using insulated tools, and wearing appropriate personal protective equipment such as safety glasses and rubber gloves. It's also important to be aware of the potential hazards of working with electricity, such as electrical shock, arc flash, and electrocution. These hazards can be minimized by following safe work practices and using appropriate safety equipment. When replacing an old toggle or duplex switch or outlet, it's also important to inspect the wiring in the box for any signs of damage or deterioration. This includes looking for cracked or frayed insulation, loose connections, and corrosion. If you find any problems with the wiring, it's important to repair or replace it before installing the new device. This will help to ensure that the electrical system is safe and reliable. It's also a good idea to label the circuit breaker or fuse that supplies power to the box. This will help you to easily identify and turn off the power to the circuit in the future. The label should include the circuit number, the location of the circuit, and the devices that are powered by the circuit. This information can be invaluable in the event of an electrical problem or when performing maintenance on the electrical system. When installing a new toggle or duplex switch or outlet, it's also important to choose a device that is compatible with the existing wiring and electrical system. This means selecting a device that is rated for the correct voltage and amperage and that has the appropriate number of terminals for the wiring in the box. It's also important to choose a device that is UL listed or otherwise certified by a recognized testing laboratory. This certification indicates that the device has been tested and meets safety standards. Finally, it's important to follow the manufacturer's instructions when installing a new toggle or duplex switch or outlet. The manufacturer's instructions will provide detailed information on how to install the device safely and correctly. Following these instructions will help to ensure that the device is installed properly and that it will function reliably for many years to come. In summary, grounding an updated toggle or duplex switch or outlet is an important safety measure that helps to protect people and property from electrical hazards. By following the steps outlined above and by taking appropriate safety precautions, you can safely and effectively ground a new device and ensure that your electrical system is functioning properly. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical safety. Now let's consider a scenario where the existing electrical box is not grounded. In such cases, you must establish a grounding path. This typically involves running a ground wire from the electrical box to a nearby grounded point, such as a metal water pipe or a grounding rod. The National Electrical Code, or NEC, provides specific guidelines for grounding electrical systems. These guidelines are designed to ensure that the grounding system is safe and effective. It's important to consult with the NEC and to follow its requirements when installing or modifying an electrical system. The NEC is updated every 3 years, so it's important to stay current with the latest edition. The NEC covers a wide range of topics related to electrical safety, including grounding, wiring, overcurrent protection, and equipment installation. It's an essential resource for electricians, electrical contractors, and anyone else who works with electricity. In addition to the NEC, there are also other resources available that can help you learn more about electrical safety. These resources include textbooks, training courses, and online tutorials. It's important to take advantage of these resources to improve your knowledge and skills in electrical safety. Electrical safety is a critical topic that should be taken seriously. By following safe work practices, using appropriate safety equipment, and staying informed about the latest electrical codes and standards, you can help to prevent electrical accidents and injuries. When working with electricity, it's always better to be safe than sorry. If you're unsure about any aspect of electrical safety, it's best to consult with a qualified electrician. They can provide you with expert advice and guidance and help you to ensure that your electrical system is safe and reliable. Let's also discuss the different types of ground wires that are commonly used in electrical systems. The most common type of ground wire is a solid copper wire that is either bare or insulated with green insulation. The size of the ground wire depends on the size of the circuit that it's protecting. The NEC provides tables that specify the minimum size of ground wire that is required for different circuit sizes. It's important to use the correct size ground wire to ensure that the grounding system is effective. Another type of ground wire is a stranded copper wire. Stranded wire is more flexible than solid wire and is often used in applications where the wire needs to be bent or flexed. Stranded ground wire is also available in both bare and insulated versions. In some cases, a metal conduit can be used as a ground conductor. Metal conduit provide a continuous metallic path back to the grounding electrode and can be an effective grounding method. However, it's important to ensure that the conduit is properly connected to the grounding electrode and that all connections are tight and corrosion-free. When installing ground wires, it's important to avoid creating ground loops. A ground loop occurs when there are multiple ground paths in a circuit, which can cause unwanted current to flow through the ground wires. Ground loops can cause noise and interference in electronic equipment and can also create a safety hazard. To avoid ground loops, it's important to use a single-point grounding system where all ground wires are connected to a single grounding electrode. It's also important to avoid using multiple grounding electrodes in a single circuit. Finally, let's discuss the importance of regular maintenance of electrical systems. Regular maintenance can help to identify and correct potential problems before they become serious. This includes inspecting wiring for damage or deterioration, tightening loose connections, and testing grounding systems. Regular maintenance can also help to extend the life of electrical equipment and reduce the risk of electrical accidents. It's recommended to have a qualified electrician inspect your electrical system at least once a year. They can perform a thorough inspection and identify any potential problems. They can also provide you with recommendations for improving the safety and reliability of your electrical system. In conclusion, grounding is an essential safety measure that protects people and property from electrical hazards. By following the steps outlined above, using appropriate safety equipment, and staying informed about the latest electrical codes and standards, you can help to ensure that your electrical system is safe and reliable. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. Remember, the electrical box serves as a crucial component of the grounding system, particularly when it is made of metal. The metal box, when properly grounded, becomes an extension of the grounding conductor, providing a low impedance path for fault currents to return to the source. This is why ensuring good contact between the grounding screw of the device and the metal box is paramount. Contact ensures continuity of the grounding path. However, as previously mentioned, if the electrical box is non-metallic, such as plastic, it cannot serve as a grounding conductor. In this case, a separate grounding wire must be run from the device to a suitable grounding point, such as the grounding busbar in the electrical panel. The grounding busbar is connected to the grounding electrode system, which provides the connection to the earth. It's also worth noting that some older electrical systems may not have a dedicated grounding conductor. In these systems, the metal conduit or the armor of the cable may serve as the grounding path. However, these methods are not as reliable as a dedicated grounding conductor, and it's recommended to upgrade the system to include a grounding conductor if possible. Upgrading the grounding system can significantly improve the safety of the electrical system. When working with older electrical systems, it's important to exercise extra caution. The wiring may be deteriorated, and the grounding system may be inadequate. It's always best to consult with a qualified electrician when working with older electrical systems. They can assess the condition of the system and recommend appropriate upgrades and repairs. In addition to grounding, there are other important safety measures that should be taken when working with electricity. These include wearing appropriate personal protective equipment such as safety glasses and rubber gloves, and using insulated tools. It's also important to de-energize the circuit before working on it. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. It's also important to verify that the circuit is de-energized using a voltage tester before touching any wires or components. Voltage testers are designed to detect the presence of voltage in a circuit. They can be used to verify that a circuit is de-energized before working on it. There are different types of voltage testers available, including non-contact voltage testers and contact voltage testers. Non-contact voltage testers can detect the presence of voltage without touching any wires or components. They are useful for quickly checking if a circuit is energized. Contact voltage testers require contact with the wires or components to detect the presence of voltage. They are more accurate than non-contact voltage testers but require more caution when using. When using a voltage tester, it's important to follow the manufacturer's instructions carefully. It's also important to test the voltage tester before and after using it to ensure that it's working properly. A faulty voltage tester can give false readings, which can lead to serious injuries. In summary, grounding is a critical safety measure that protects people and property from electrical hazards. By following the steps outlined above, using appropriate safety equipment, and staying informed about the latest electrical codes and standards, you can help to ensure that your electrical system is safe and reliable. Always consult with a qualified electrician if you have any questions or concerns about electrical safety.